Welcome to Emtron Training Part 39. In this training tutorial, we're going to be taking a look at working with our basic idle control. Our basic idle control is going to look at the fundamentals of how idle control is going to work and how we can replicate basic idle control on any race engine. Now, basic idle control assumes that you're not having an idle control motor, and we're purely going to be controlling the airflow through the throttle plate opening, as well as integrating a spark timing characteristic or offset to maintain a desired idle torque to hit the desired idle speed that we want to idle at. So there's a lot to cover and talk about. Let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at working with programming our basic idle control within our Emtron ECUs. Our basic idle control assumes that we're going to have a cable-driven throttle body, we're not going to have an idle control motor, and that we want to be able to influence the engine's torque production to hit a desired idle speed that we want to idle at. It's actually relatively simple in order to work within the basic idle control tuning with the Emtron, but there is going to be a lot of specific things we need to pay attention to and understanding the concept of what we're actually trying to accomplish. Let's jump in here and talk about where we can start to look for the idle control tables and then how this is actually going to work. What we're going to do here is move from our fuel area, and we're going to go in here to engine functions. Under engine functions, we'll find we have our idle speed control, and we find our idle ignition control. Dealing with the basic type of idle control, where we're allowing a fixed amount of airflow into the engine, we'll use spark timing as a means to influence the engine's torque output to achieve the desired idle speed. What we'll find is we have a relationship between airflow and spark timing, and what's going to be influence the actual torque of the engine. More airflow, more torque. More spark timing, more torque. If we have a combination of both airflow and spark timing, we have a lot more torque production. Now, if we reduce the airflow or reduce the spark timing, we're reducing the engine's torque production. So we have this kind of a seesaw effect where if we increase the airflow and decrease the spark timing, we could have the same engine torque production out of the engine. Likewise, if we decrease the airflow and increase the spark timing, we'll have a similar torque production out of the engine. Our goal is to have one variable moving and then have another one fixed. Within the basic idle control, we want to fix the airflow coming into the engine and use spark timing as a means in order to achieve the desired torque output out of the engine. Now, what we'll find is that airflow will be the course adjustment typically in terms of the engine's torque production at idle. So what that's going to mean is if we have a change in airflow, we'll have a more reactive or larger difference in engine torque compared to changing the spark timing. So what we'll find is that we want the majority of the engine's torque production coming from the airflow, but having that airflow amount fixed. So the torque production is going to be relatively fixed. And then we can use spark timing as more of a refined, quicker, almost instantaneous feedback in order to influence what the engine's torque production is going to do. So it's a finer control compared to airflow. But what we're trying to achieve, steady state airflow, course type of production of the engine's torque, probably 80-90% of the torque production, and then the spark timing will influence the rest. Again, the idle torque will influence the idle speed. In idle conditions, we want our idle RPM to be in a certain range, and the only way to achieve that is to start to pair together things here within airflow and spark timing in order to accomplish that desired idle speed and indirectly the idle torque. All right, this is going to be where we start to work with the programming in these tables here. We also have our idle speed control. We're going to talk about this in the upcoming training tutorials. This is going to be where we program and work with an idle control motor. So whether it's a stepper motor or a pulse width modulated type of motor, an idle control motor is going to have an airflow bypass from our throttle plate. That'll essentially allow a moving amount of airflow to vary based on a variety of conditions. Now, we can run the engine in that type of idle control, working within that, but it is going to be a little more complicated. So I'm going to strip this down, and that's why we're just focusing on this basic idle control, because the majority of race engines can just work with a basic idle control. They don't even necessarily need an idle control motor. Idle control motors are really more suited to cold starting, and if we have something like air conditioning kick on, where we need to have a large torque offset, we can use the idle control to accomplish that. But what we're finding is that the basic idle control can suit majority of race applications. We can get the results that we're after and having a stabilized idle in idle conditions. So these are the two areas where we're going to potentially work within the programming for idle control. Now I want to go over something very quickly here before we actually talk about how we can influence what the spark timing is doing to vary the amount of engine torque to achieve that desired idle speed we want to be at. We have to understand the relationship between our idle spark timing and the main spark timing table. If we go take a step back here into ignition under main ignition, this is where we command the main spark timing to happen at. So we know this is the base amount, this is where it's going to source from. We have our corrections that are applied on top of this. Knock control can pull timing away from the base spark timing values in our table. If we take a look right now, the cursor is showing me I'm idling right here at roughly 1,000 RPM, 40 kPa, so we're right here. We should find that our spark timing delivered to the engine is around 22, 24 degrees. When we actually take a look at the ignition angle of what's actually delivered to the spark plug, we're about 16.3 degrees. And then we'll find the ignition base angle is showing about the same, it's matching. Now in this particular situation, this does not match what's coming from my...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.